This video is brought to you by mywayteaching.com.
So in this part, let us solve few problems. The first problem is find the magnitude and direction of the resultant of two vectors A and B in terms of their magnitudes and angle theta between them. So here they have given two vectors A and B. So we should find the resultant magnitude and the angle theta between them. Okay. So for this, let us consider a simple figure. Let OP and OQ represents the two vectors A and B. Okay, we should find the resultant vector of these two vectors, that is OP and OQ. So it represents the vector A and vector B are the two vectors, and we should find the resultant vector of these two vectors. Okay, and it makes an angle theta. The angle theta, see, this is an angle theta between vector A and vector B that we should find. And then using parallelogram method of vector addition, OS represents the resultant vector R. Okay, by using the parallelogram law, we are extending this point Q to S and from P to S, and we are forming a parallelogram, and the resultant vector is represented by the the line OS. OS is the resultant vector. Okay, the resultant vector is OS, and we know that the resultant vector can be found out by adding the vectors A and B, isn't it? Yes. And Sn is normal to OP and PM is normal to OS, isn't it? You can see in this figure the Sn is normal to OP. Sn is normal to OP and PM is normal to PM is normal to OS. Okay, you can see here this PM is normal to OS, isn't it? Okay, this Sn is normal to OP. Okay, OP and PM is normal to OS, isn't it? You can see in this particular figure. And from the geometry of the figure, we can write OS square is equal to ON square plus Sn square. Okay, OS square is equal to ON square plus Sn square. Hypothesis, we can write it, the OS is square is equal to ON square plus Sn square. Okay, and we know that ON is equal to ON is given by OP plus PN, isn't it? You can see in the figure. And OP is nothing but vector A. What about PN then? PN is nothing but, yes, PN is a component of vector B. We can write it as B cos theta, isn't it? It is, you can see in this figure, we can write it as B cos theta. So this is about ON. And we can write Sn as what? Okay, yes, we can write Sn as B sin theta. And substituting all this in OS square, we know OP is equal to what? ON is equal to OP plus PN, that is A plus B cos theta, whole square, plus we know Sn is equal to B sin theta whole square, isn't it? So if you simplify this, OS is nothing but R square. OS square is R square, and A plus B cos theta whole square, we can write it as A square B square cos square theta plus 2AB cos theta, isn't it? And we can write it as B square sin square theta. And if you can take A square plus B square, you can take common, we'll get cos square theta plus sin square theta plus 2AB cos theta. Okay, and we can write the resultant vector R as A square plus B square, because cos square plus sin square theta is 1, plus 2AB cos theta. So this is the magnitude of the resultant vector. Now we should find the angle theta. Okay. So by considering the same figure, okay, in triangle OSN, okay, you can consider the triangle OS and N. Okay. In triangle O, S and N. So in this particular triangle, Sn is given as OS sin alpha, OS sin alpha. So OS is nothing but R. So it is R sin alpha. And in triangle PSN, we can write Sn is equal to PS sin theta, and where PS is given by the vector B sin theta. Okay. Therefore, we can equate these two, isn't it? That is R sin alpha is equal to B sin theta. So R by sin theta is equal to B by sin alpha. Similarly, we can also write the side PM, which is normal to OS, as A sin alpha, that is equal to B sin beta. So we can write it as A sin beta is equal to B sin alpha. So if you consider this equation and this equation, we can combine these two equations, and then we will get one more equation, that is given by r sine theta, r by sine theta is equal to a by sine beta, that is equal to b by sine alpha. So, if you simplify this using if you consider this equation, we can simplify it, or we can take any two equalities, and what we want is sine theta, that is the value of theta, isn't it? So sine theta, we can write it as b by r sine theta is equal to sine alpha by considering first and the third one, okay, where r is given in the equation. So we already found out the value of r, isn't it? That is given by a square plus b square plus what? 2ab cos theta. This is the value of r, isn't it? And we can write tan alpha as Sn OP plus Sn by OP plus Pn. So Sn can be written as b sine theta. We know this, isn't it? And OP can be written as A, the vector A, and Pn is nothing but b cos theta. So using equation of this r, the magnitude of r, we can find the magnitude, isn't it? And using the equation, that is b by r sine theta is equal to sine alpha, as well as tan alpha is equal to b sine theta by a plus b cos theta, we can find the direction, okay. And if you can, okay, using this equation we can find the magnitude of the resultant vector, and using this equation we can find the direction. We can also use the tan alpha equation to find the direction of two vectors. Okay. And the magnitude equation, that is called as law of cosines. Okay. The equation that we got for the resultant vector's magnitude is there, no, this, the value of r is used to find the magnitude, and this is known as, this equation is known as law of cosines. And the equation that is written here, r by sine theta is equal to a by sine beta is equal to b by sine alpha. This equation is known as law of sines. So using this equation we can give a number, and for this we can give a number as 4. We can give, for this we can give a number as 5, and we can give a number 6. So using the equation 5 we can find the magnitude of the resultant vectors a and b. and using equation 4 and 6 we can find the direction of the resultant vectors a and b, the angle theta between them. We can find that by using the equations 4 and 6, and that the equations which are used to find the magnitude is called as law of cosines, and that equation which is used to find the direction is called as law of sines.